Good morning, students. How are you? So, yesterday we discussed about polarization, power, polarizability, and VBT, and in that one, sigma bond, pi bond also we discussed. So, here note point related to the sigma bond and pi bond. Sigma bond is formed in the hybrid orbitals or with the hybrid orbitals, and pure orbitals are involved in the pi bond formation. So that one note important. Hybrid orbital forms sigma bonds, whereas pure, that is pure orbitals, that is unhybrid orbitals, forms pi bond, pi bonds. So here sigma bond is a localized bond and pi bond is a delocalized bond. Okay, this is yesterday's related to one. And one more one is here we have very important concept, that is positive, negative, and zero overlap of S and P orbitals. S and P orbitals. What? Positive, negative, and zero overlap of S orbitals and P orbitals. So here zero overlap. Before that, how can we classified positive, negative, zero overlap? Based on the characteristic properties of atomic orbitals. Here overlapping formed bonds that may be positive, negative, and zero overlappings. And here zero overlaps involved in bond formation that may be zero, negative, and positive. Okay, so here zero overlap means the overlapping is not possible and they cannot form the bonds. So for that I am taking an example here. Here Px and Py, these two orbitals are not overlapping and they cannot form the covalent bond, and similarly s orbital and px orbitals, s orbital and px orbitals also not involved in the overlap process and cannot form the covalent bond. Why they are not forms the covalent bond? Due to their directionals. Their directions are not in same. So that's why here these two are not involved in the bond formation, and these two are also not involved in the bond formation. Then it is example for zero overlap. Okay. Then next one is positive overlap. Positive overlap. So positive overlap. Suppose we have p orbitals px, py, and pz. So here I am taking pz. Suppose here PZ, and one more PZ orbitals. Here this is positive lobe and this is negative. This is positive and this is negative. So whenever these two are here, once observed, they are in the same direction, then they are undergoes linear combination overlap and forms Z. So here positive, here also positive and negative, negative. So this is PZ, that is sigma PP, like, okay. Then next one is, suppose I am taking a positive overlapping, so same lobes. Then next one is PX. Suppose imagine this one is PX, this is also PX, and that one is here positive and negative. So whenever these are overlapped, now here see, this is overlapped place, and here this is positive and negative. Like this one is examples for positive overlap. Similarly, PY plus PY also. Okay. Then negative overlap. Negative overlap is also occurs between these two PZ and PZ orbitals. Once observed here, PZ orbitals. This is positive and this one is negative, and this one is positive, this one is negative, and forms like this is positive, this is negative, this is positive and this. So this overlap is a example for negative overlap. Similarly, negative overlap is also occurs between Px and Px orbitals, and here I am changing simple. Now this one is a negative overlap concept, and this one positive, negative and zero overlap concepts. Okay. Okay. Now this is our concept, and that concept related to problems these are. So first problem, which of the following have both polar and non-polar bonds? So here once observed, first option C2H6, CH4Cl and HCl and AlCl3. So polar bond and non-polar bond. Polar bond is exist between the dissimilar atoms are different electronegativity values, and non-polar covalent bonds exist between the like atoms are nearly same electronegativity atoms. So here which one is having both polar and non-polar? So here this is purely organic compound, and once observed second option, in that one NH4 gives NH4 plus and Cl minus. So here plus minus indicates polar one, and in that one once Once diagram observed, this is the polar nature. This is what in between nitrogen and hydrogen bond is non-polar in nature. So answer is second one. And the next one is next question is the polarizing power of the following anions. That anions is N-3, O-2, F minus. Okay. So here options. What they are asking? What is the correct order? So polarizing power yesterday we discussed with respect to cation. So what I said yesterday is polarizing power is depends on the size of cation. So here size of cation is increases, the polarizing power should be decreases. So here what polarizing power is increases by the decreasing of size of cation decreases. Similarly, polarizing power is increases by the increasing of size of anion. So anion size increase avute, polarizing power also increases. So based on this clue point, now you should select the correct order. So what they given, how many anions? We have 3 anions. In that one -3, that is N-3, O-2 and F -1. So in this one, which anion having more or larger in size? Which one the negative charge is high? That one is larger. Now here N-3 is larger than O-2 and F-1. So which one is having highest polarizing power? Nitrogen, then oxygen, then fluorine. So which one is correct option? Second one is correct option. Okay. Okay. Then next third one. Amongst lithium chloride, RbCl, rubidium chloride and beryllium chloride, BeCl2 and MgCl2, the compounds with the greatest and least ionic characters. So I think we discussed yesterday's FAJAN'S rule. So FAJAN'S rule explained about ionic as well as covalent characters. So based on size of cation and anion. Okay, here remember what they asked first of all. Ionic character, highest, that is greatest and least. So ionic character according to FAJAN'S. According to FAJAN'S rule, here most favorable condition for ionic bond, that is what? Smaller anion and larger cation. So out of 4 compounds here, once observed 4 compounds having same anion only, then you can decide ionic nature based on cation. And once observed lithium is in LiCl, lithium is having +1, and whereas RbCl, rubidium also having +1, and here beryllium, BeCl2, in that beryllium having Be+2 and MgCl2, cation is magnesium, Mg+2 ions. Once observed in this one 4 cations, which one is larger in size? Which one is here? Already we know charge is increases, size of cation is decreases. Okay, leave it about that. Now see here, lithium and beryllium are same group element, and lithium and rubidium having same group elements, and in this one rubidium is a larger cation, and whereas larger cation is, we know, out of this four rubidium is a larger cation, then rubidium contained compound is greatest ionic character, and next identify which cation is smallest. So BeCl2 is a smallest when compared to the lithium plus 1. Okay, so here beryllium contained compound is BeCl2, then this compound having BeCl2 having least ionic character. So easy ga manam identify chesesam. Then ikkada options chudandi, rubidium chloride and beryllium chloride, greatest and least. So second option is correct. Okay. Then fourth question is, which of the following species contains equal number of sigma and pi bonds? Equal number of sigma and pi bonds. So once observed in this molecule, first molecule Cn taken twice. That means Cn taken twice means C2N2, C2N2. Now we should draw the diagram of C2N2. C single bond C, triple bond N, single triple bond N. So this is a diagram of C2N2. This diagram ni base cheskoni easy ga manam identify cheyochu. Now how many sigma bonds in this one? 1, 2, 3. 3 sigma bonds. Then pi bonds 1, 2, 3, 4. So 4 pi bonds. 4 pi bonds. So what is our question? Equal number of sigma and pi bonds. Is there equal number of sigma and pi bonds? No. 3 sigma bonds and 4 pi bonds. Then second option, see. Second option is xenon tetraoxide. So here this molecule diagram observed, already well known. Okay. Now see here how many sigma bonds, how many pi bonds. This is sigma, this is also sigma, this is also sigma, this is also sigma. Already yesterday I said double bond means what? 1 sigma bond, 1 pi bond. Triple bond means 1 sigma bond, 2 pi bonds. So here how many double bonds? How many double bonds? 1, 2, 3, 4. So each double bond having 1 sigma bond and 1 pi bond. Then here this molecule having equal number of sigma bonds and pi bonds. Equal number of sigma bonds and pi bonds. So option is second one. Second one. Then next one is molecule C3O2 as a linear structure. What is చెప్పేసారు మనకి ఈజీగా ప్రాబ్లం లేకుండా. ఏమని చెప్పాడు? C3O2 molecule has a linear structure. Then the compound has ఏముందండి compound లో? ఏంటి 4 sigma bonds, 4 pi bonds ఉన్నాయా? And లేదా 3 sigma bonds, 2 pi bonds ఉన్నాయా? Or 2 sigma bonds, 3 pi bonds లేదా 3 sigma bonds, 4 pi bonds ఉన్నాయా అని అడుగుతున్నాడు. సో C3O2 diagram observation చేయండి మీరు. C double bond, C double bond, double bond O, double bond O. Now carefully observe here. Carbon valency is 4 satisfied. At the same time oxygen valency is 2 satisfied. So here now only I said double bond means 1 sigma bond, 1 pi bond. So here one double bond, here also one double bond, here also one double bond, here also one double bond. That means C3O2 has 4 sigma bonds, 4 pi bonds. 4 sigma bonds, 4 pi bonds. The answer is 4 sigma and 4 pi bonds. So these are some problems related to the FAJAN'S tools and VBT. So very important for competitive side. Okay, next topic is formal charge. So very easy, and just we should remember the formula, how to calculate formal charge concept only, and we don't want here definition, but I am writing here what is formal charge. What is formal charge? Formal charge. What is formal charge? Formal charge is the charge on the atoms in a given molecule. Okay, and assuming that all electrons in a chemical bond are shared equally in between atoms, regardless the relative electronegativity. So this is the formal charge definition. So what is formal charge అనేది సింపుల్ గా అర్థం చేసుకోండి. సో ఫార్మల్ చార్జ్ అనేది ఏంటి? ఇది ఒక చార్జ్ దట్ వన్ ఈస్ ప్రెసెంట్ ఆన్ ది atoms in a molecules, and ఏమని చెప్తున్నాడు? assuming that all electrons in a chemical bonds are equally shared between the two atoms, irrespective సంబంధం లేకుండా దేనికి రిలేటివ్ ఎలక్ట్రోనెగటివిటీ కి. సో దాన్ని ఫార్మల్ చార్జ్ అంటారు. సో ద చార్జ్ అసైన్ టు ది ఆల్ ది ఆటమ్స్ అని కూడా చెప్పవచ్చు. సో హియర్ important, formal charge on the atoms may or may not be same. It can changes with the structural environmental of the atom in a molecule. Very important this one. It is what? Formal charge is always formal charge is formal charge of all atoms may or same. It changes with the structural environment of atom in a given molecule. This is another important condition. Then students, here by using of simple formula we can calculate the formal charge of atoms. Okay, so here formula is formal charge is equal to number of valence electrons minus number of electrons in a lone pair minus 1 by 2, number of electrons in a bond pair. So this is the formula, and this is very important concept. So competitive side lo ee formula gurtu pettuకొని మనం ఫార్మల్ చార్జెస్ ఈజీగా క్యాలిక్యులేట్ చేయవచ్చు. సో వాట్ ఈస్ ఫార్మల్ చార్జ్ ఫార్ములా? నెంబర్ ఆఫ్ valence electrons minus number of electrons in lone pair minus 1 by 2 number of electrons in bond pair. Okay, then okay, next one, examples how to calculate the formal charge of each atom in a given molecule. So here first one is the previous examinations asked O3 formal charges. So first of all we should draw the structure of O3, that is ozone diagram. That is ozone Lewis dot structure. So ozone valence is 6, here 1, 2, 3, 4, and 5th, 6th is involved in bond formation with another oxygen atoms here. Then so this is the Lewis structure of O3 ozone molecule. Now I am giving the numerical 1, 2s for these oxygen atoms. This is, suppose imagine 1, this is 2, and this one oxygen atom is 3. So how can you calculate a formal charge of each oxygen atom in O3 molecule? So simple, remember this formula. Formula is number of valency electrons minus number of lone pair of electrons minus 1 by 2 number of electrons in a bond pair. So here this is the diagram. By using of Lewis dot structure we can easily calculate in the formal charge of each oxygen atom in O3. First, here first one is first oxygen. So what is formal charge? Number of valence electrons. Oxygen having how many valence electrons? 6. Already you know. Okay. Number of electrons in lone pair. So how many lone pair in the first atom? 2 lone pairs. So 2 lone pairs having how many oxygen? How many electrons? 4 electrons. So minus 4 minus 1 by 2. And here number of electrons in bond pair. So once observe, this oxygen is bonded having how many bonds? 2 bonds. So each bond having how many electrons? 2 electrons. So total electrons in bond pair is 4. So here 4. So 2, then 6 minus 6, it is 0. So what is the formal charge of first oxygen atom? 0. This 0. Then next second. This is second, it means this one. Second oxygen formal charge is again number of valence electrons 6 and number of electrons in lone pair. So here how many lone pairs observed here once carefully?